Hey everyone, and welcome back to the channel. Today we're tackling LeetCode problem 26, remove duplicates from a sorted array. This is a classic problem, often showing up in coding interviews, and it's a great way to understand dynamic programming concepts. The problem statement is pretty straightforward. Given a sorted array of integers, we need to remove the duplicates in place such that each element appears only once and returns the new length of the array. The key here is in place, meaning we can't create a new array. We have to modify the existing one. We'll also be constrained by not using extra memory proportional to the input array's size. So let's dive into understanding this problem in more detail. We'll explore different approaches, and of course, we'll find the most efficient solution. Understanding with examples. Let's clarify things with a couple of examples. Imagine we have the array 1, 1, 2, 3, 3, 4. After removing duplicates, we want the array to become 1, 2, 3, 4, and the function should return 4, which is the new length. Another example, 0, 0, 1, 1, 1, 2, 2, 3, 3, 4. The result should be 1, 2, 3, 4 with a returned length of 5. See how we're keeping only the first occurrence of each number? The order of the remaining elements must be maintained. This is crucial. Now that we've visualized the problem, let's consider some approaches to solve it. Brute force approach. A naive approach might involve creating a new array, iterating through the original array, and only adding unique elements to the new array. This is simple to understand, but it's not in place, and it uses extra space. We could also use nested loops to compare each element with every other element, and then removing duplicate elements directly within the original array. But this brute force approach would lead to a time complexity of O of n squared, which is not efficient for larger input sizes. It's perfectly acceptable for small data sets, but imagine running this on an array with millions of elements. It'll take forever. So let's explore a much more efficient solution. Optimal solution. The optimal solution utilizes a two-pointer technique. We'll use two pointers, a slow pointer and a fast pointer. The slow pointer will track the unique elements, and the fast pointer will iterate through the array. Initially, both pointers point to the beginning of the array. As the fast pointer encounters a new unique element, different from the element at the slow pointer's position, we move the slow pointer one step to the right and copy the value from the fast pointer's position to the slow pointer's position. This way, we're efficiently overwriting the duplicate values. The slow pointer will always point to the next position where a new unique element should be placed. Code implementation. Let's see the code in Python. We'll define a function removeDuplicates that takes the input array nums. We initialize our slow pointer to 0. Then we iterate with the fast pointer. If nums at position fast is different from nums at position slow, we increment slow and copy the value from nums at position fast to nums at position slow. Finally, we return slow plus 1 because slow points to the last unique element and we need the total count. It's concise and efficient. Time and space complexity. Our optimal solution boasts a time complexity of O of n because we're iterating through the array only once. The space complexity is O of 1 because we're not using any extra space proportional to the input array size. We are modifying the array in place. This is a significant improvement over the brute force approach, making it suitable for handling large data sets efficiently. This is a great example of how choosing the right algorithm can dramatically impact performance. Engagement break. So, what did you think of that solution? Did you find it helpful? Let me know in the comments below. And if you found this video useful, don't forget to like it and subscribe for more coding tutorials. Also, share this with your friends who are preparing for coding interviews. Hit that notification bell so you don't miss out on future videos. Let's keep learning together. Conclusion. We've successfully tackled the remove duplicates from sorted array problem. We explored different approaches, focusing on an optimal solution that uses a two-pointer technique to achieve O of n time complexity and O of 1 space complexity. Understanding this problem and its efficient solution is extremely valuable for coding interviews.